Today we're going to be going over how to solve a system of equations by graphing. So in our calculator today, we're going to be using it to graph two lines instead of just one line today. So a system of equations is two or more linear equations that use the same variables forms for a system of equations. So the solution to our system of equation is going to be the ordered pair that makes all of the equations in the system true. The following types of solutions are possible when solving a system of linear equations. The first possibility is going to be one like the one below where they cross and form an x. This is called one solution. One solution means that they cross at exactly one point. These lines have different slopes and intersect at one point. That point of intersection is going to be x, comma, y. The next two lines that you see have no solution. These two lines are running parallel and will never intersect. So lines that have the same slope but a different y-intercept don't intersect and have no solution. The last one is going to be infinitely many. This line is a line on top of another line, so they have infinite solutions in common when we have a line on top of a line. So these lines have the same slope and the same y-intercept. When a system of linear equations is graphed, we can find the solution to the system by looking at the point of intersection. The first problem we're going to work says y equals negative x minus 2 and y equals half x plus 7. We're going to try to find the point of intersection by graphing it on our paper. So the first equation has a y-intercept of negative 2. So we're going to put a point at negative 2. Our slope is negative 1, which means we're going to go down 1 to the right 1, down 1 to the right 1. Now we can plot all of our points going down 1 to the right 1 through our graph, and we can also go the opposite direction. The more points we have on our graph, the more accurate our intersection will be. So notice I just followed the pattern throughout my entire graph, and then I'm going to connect the points. After that, we're going to graph our second equation, which says half x plus 7. So go up to positive 7 on the y-axis, and our slope is up 1 to the right 2. Since I can't go up 1 to the right 2 anymore, we're going to go the opposite direction. Down 1 to the left 2, down 1 to the left 2, and so on until we get through our graph. Our solution is the point where those two lines intersect. That is our solution. So we're looking at exactly where the two lines cross, which is at negative 6, positive 4. This is called the solution to our graph. Now we can also check it by using our calculator, so let's use our calculator to check it. We're going to go to our graph, and we are going to type in our first equation, which says negative x minus 2. When you push enter, this bar is no longer up here. So to get the bar to pop back up, you're going to push tab. And now we're going to type the second equation, which says half x plus 7. We can see both lines intersect right here, but we're trying to find the exact intersection. So to do that, you're going to click menu, and then you're going to go down to where it says 6, analyze graph, and 4, intersection. You're going to go to the left side of your graph and click the center button, drag across, and notice that I'm just shading this area, and in the shaded region, it is telling me the point of intersection in that shaded portion, which is negative 6, positive 4. So again, if you want to write yourself a note off on the side for number 1, put to the side menu, 6, 4. Problem number 2, y equals half x plus 6 and y equals 2x over 4 minus 3. So for the first equation, we're going to have a y-intercept of 6, so we're going to put a point right at 6. Our slope is 1 over 2, so we're going to go up 1 to the right 2, up 1 to the right 2. Now because we ran out of space over here, we can also go the opposite direction, which is down 1 to the left 2, down 1 to the left 2, and plotting our points through our graph, which forms our first line. The second line is y equals 2x over 4 minus 3. So we're going to go down to negative 3, plot a point, and our slope is up 2 to the right 4. up 2 to the right 4. If you simplify that, it also simplifies to 1/2 x, which means we can also go up 1 to the right 2, up 1 to the right 2. When we graph both of these lines, you'll notice that they're both parallel. Parallel lines never cross each other, so that means that our solution is no solution. These two lines don't cross each other. Problem number 3. We have x equals 3, which means that it is a vertical line going straight through 3. And we also have y equals 1/3 x minus 7. So we're going to go down to -7, and our slope is up 1 over 3 to the right 3. Up 1 to the right 3. Plot your line. And here our solution is 3, -6. For problem number 4, we have x minus 2y equals 8, and another equation that is not in slope-intercept form. We're going to start with the first one, x minus 2y equals 8, and we're going to change it to get y by itself, which is slope-intercept form. I'm going to start by subtracting x from both sides. That'll leave you with -2x equals -x plus 8. Next, we have to divide by -2. So our equation for the first one is going to be y equals 1/2 x minus 4. When I graph my first line, we go to -4 on the y-axis, and our slope is up 1 to the right 2. Up 1 to the right 2. We can also go the opposite direction by going down 1 to the left 2. Our second equation says 3x plus 4y equals 4. We're going to take 3x's from both sides, which leaves you with 4y equals -3x plus 4. And next, we're going to divide by 4. So the equation for the second line is going to be y equals -3 over 4x plus 1. Our y-intercept is 1, so we plot a point at 1. Our slope is -3 over 4, so we're going to go down 3 to the right 4. You will notice that we already have a point on the other line going through that point. So that means our solution is 4, -2. Again, if we want to check in our calculator to make sure that the solution is correct, we would go ahead and go to our graph, open up your graph, type in the first equation, which said 1/2 x minus 4, enter. To get the line back up here, you're going to push tab, and then we're going to type our second equation in, which said -3/4 x plus 1. And to see where they both cross, it's going to be menu 6 and 4 to find the intersection. So the intersection of this graph is 4, -2, which matches what we ended up with on our problem, 4, -2. Problem number 5. We have y equals 2x minus 4. So here we're going to go ahead and graph this one since it's already in slope-intercept form. Our y-intercept is -4, and our slope is up 2 to the right 1. Up 2 to the right 1. Our next line is not in slope-intercept form, so we have 2x minus y equals 4. We need to move the x's over. You'll have -y equals -2x plus 4, and then we divide both sides by -1. So the second equation is y equals 2x minus 4. That means we go down to -4, and our slope is up 2 over 1. Those points lie on the same line that we already have. So when we have a line being graphed on top of another line and we're trying to figure out how many points they intersect, this is going to be infinite solutions. Problem number 6. List the system of equations represented on the graph as well as the solution. So looking at this, we have two lines. We're going to start with this first one, and we're going to call this one line 1. We have to first find our slope and y-intercept in order to get the equation of that line. So starting with the y-intercept, you'll notice it hits the y-axis at 90. So that means it's going to be plus 90. We also have to find our slope, and notice it's going down 10 and then across 2. So negative 10 over 2, that means negative 5x plus 90. Line 2. Line 2 is going to be this bottom line that we have. And again, we have to find the slope and the y-intercept. The y-intercept hits right here at positive 10. Then we need another point on our line. It's going up 10 and across 2. This one has a slope of positive 5. Now that we have both equations, it's asking what the solution is. The solution to our system is where the two lines cross, which is 850. Problem 7. Joel's opened a checking account with $500 and plans to spend $50 each week. Astrid opened a checking account with $50 in it and plans to save $25 each week. Write an equation representing X, the number of weeks, and Y, the account balance in each account. We will first start with Joel's account. It's going to be Y equals, he started with $500, so 500 is by itself, and he's spending, which means minus 50 a week. Going to your graph, we're going to go ahead and plot a point at 500. And since he's spending 50 every week, after 1 week, he is down $50, which is $450. After 2 weeks, he's at $400. 3 weeks, $350. You can continue this pattern going down your graph. Next, we're going to move on to Astrid. Astrid has $50 in his account, and he plans to save, which means add, 25 every week. Therefore, we're going to go to our y-axis, and we're going to start him at 50. Since he's saving 25 every week, if you notice your y-axis is going by 50s, so after 2 weeks, he will be at 100. 4 weeks, he'll be at 150. 6 weeks, he will be at 200. So here is Astrid's line. The question says, where do the two lines intersect? Intersect is our solution to the system, which is 6, 200. This is where they cross. What does this point of intersection represent in the context of our situation? So the 6 represents 6 weeks. So we're going to write 6 weeks. And the 200 represents $200. So after 6 weeks, both accounts will have $200, which is the same amount.